My name is Mengyi, and I am a solutions engineer for WhatsApp. I'm based in Singapore, as Emna shared, and it is like 8 p.m. for me now. And this is my first ever Nordic conference that I have ever attended. So I'm very excited to be here, although this is a virtual event, but I am as excited as I was when I was attending a real event. So as a software engineer, I am passionate about building great products. And as a solutions engineer, I have more opportunities to interact with the actual businesses using our products, more than most of the other software engineers. And I have come to understand that building a great product is more than writing clean codes or building clean architectures. It also involves lots of other processes, such as marketing, operations, and support. And I believe as software engineers, we should also care about these processes because they are equally important, if not more important factors contributing to the success of a product. And today, my talk will focus mostly on one aspect of product, and that is about scale. Specifically, I will share experiences about getting our product ready for scale with Python at WhatsApp. But at first, let's imagine a situation where you just had a launch, you just launched a new product, or you launched a major feature. Your marketing team has done a great job getting lots of tractions on media and social media, and users are flooding in to sign up for your product. It was a moment of glory and celebration, and your team are patting each other on the back. All is great. But I want to break a news to you. This is just a beginning. With the new waves of incoming users, you not only need to prepare your infrastructure and code ready to scale up to the increasing demand, you also need to scale up your processes to ensure that a great user experience is preserved. And that is the focus of this talk. Today, I want to share 3 practices that I found useful to prepare your product for scale. They are the automation of processes, building self-serve tools, and establishing a community. And I will start with the first practice, the automation of processes. But to set the context of the following presentation, I want to just give a brief introduction of the product that I have been working on for the past 2 years, and that is the WhatsApp Business API. WhatsApp Business API is a product that we launched in closed beta about 2 years ago. And it is a business API that allows scalable communications for medium or large businesses and organizations to have conversations on WhatsApp with their customers or community. Some businesses using the WhatsApp Business API include KLM, which is the Dutch airline. They will send boarding passes to their customers automatically before they board. And the customers can also reach out to KLM on the same WhatsApp number about customer service requests. Of course, in this day and era, it may take some time before we can travel again, especially on plane. So a more recent example of organizations using the WhatsApp Business API is the World Health Organization, WHO. They built a chatbot using the WhatsApp Business API so that people all around the world can talk to the bots and check the latest numbers and news about COVID. WhatsApp, being a communication channel, is special because it is an end-to-end encrypted channel. What that means is that a message is encrypted the moment it left the sender's phone and is only decrypted when it is received by the recipient's device. This means that only you and the people you are communicating with can read the message. Nobody in between can, not even WhatsApp. Normally within a communication between two WhatsApp users, the app installed on each user's phone will encrypt and decrypt the messages. But to transform the WhatsApp into a business API that allow scalable and automated communication, we need another way to do this encryption and decryption of messages. The way we do it can be showcased by this simplified version of the WhatsApp Business API architecture. On the right-hand side, we have the normal WhatsApp app or web users. And to ensure that the messages are end-to-end encrypted when it's reached the WhatsApp infrastructure, the businesses on the left-hand side need to deploy a set of Docker containers in their data center. These Docker containers play the same role as the WhatsApp app installed on a user's phone, which means that it will encrypt the messages when the business wants to send messages to the customers, and it will decrypt the messages when the business receives messages from the customers. The way WhatsApp distributed these WhatsApp Business API Docker images, which we also call it the Business API client, several things happen. If a new version is scheduled to release, the WhatsApp team will build one Docker image for one component in the system based on Docker files. Then the team will upload the Docker images into a public Docker registry. Then the new version is announced, and businesses will be able to download and install the Docker containers in their own data center. We are essentially distributing a package software that we ask the users, in this case, the businesses, to install in their own environments. And managing package software is challenging in the following two ways. Firstly, we have no control over the environment where our software will be running from. Secondly, whenever the user wants to upgrade this application, they have to download the new version, test it out before they can install the new version. All of these steps makes the release cycle longer than if you have full control of the environment and the release process. You may be thinking that this is not a big deal. It's just take a little bit longer to adopt a new feature or a bug fix. Well, you are theoretically true in that sense, but it becomes tricky when it comes to security. Let's refer back to the distribution model of the WhatsApp Business API containers. In the first step, when the WhatsApp team built the Docker images for each of the components in the system, several steps happen. Firstly, we will get a base image, such as a Ubuntu Docker image. Then we will install some common libraries, such as Python. And lastly, we will run some custom scripts to configure the application, such as creating directories and exposing ports. There is a chance of introducing vulnerabilities into the final Docker image in each of these three steps. For example, the base image itself may contain vulnerabilities. The libraries that we install may contain vulnerabilities as well. And the way that we run the custom scripts may also introduce vulnerabilities. These vulnerabilities, if not taken care of, will end up in the public Docker registry and will end up in the business's data center. And if we recall the two challenges of managing package software, it means that whatever version that the business has downloaded and installed in their own data center is potentially going to be there for a little while. And if vulnerabilities are part of that, it's going to stay there for a while too, which is not good. We all know the essence of holding a high bar when it comes to security. So the team jumps right in to address the container vulnerability issue. Although the process is a little bit brute force, Initially, one lead engineer on the team will use a container vulnerability scanning tool to manually scan all of the Docker images, and then right before the release, which means that there a lot of rework needs to be done to fix these vulnerabilities. And even worse, lots of tests needs to be redone on this new image. All of this has become a big burden on this one engineer that he delegated this responsibility to the release engineer of each release. And then nobody is happy because of that. We all know that security is important. On the other hand, we also want to take care of the team and also to keep our releases on track. But this manual container vulnerability scanning process always took a heavy toll on the release process. As one, here is one quote from one of my favorite authors. His name is Jess Humble. He famously said in one of his books called Continuous Delivery that if something hurts, you should do it more often. It may seem counterintuitive in the first look, but if you really think about it, when you do something more often, it normally pushes you to think about ways to automate the process. And that is exactly what I did. At the beginning of this year, I have decided to fix this manual process and save my teammates from the forever sufferings of this old manual process. What I did is very simple. I just wrote scripts to build and scan the Docker images for vulnerabilities on a daily basis. I will archive the scanning results every day. And at the beginning of each week, I will compare the results from this week to the results from last week to compare if there are any new vulnerabilities. If there are, I will just assign a task to the team so that they can fix this vulnerability as soon as they are discovered. This new process not only automates the verbose container vulnerability scanning process, but it also allows the team to address these vulnerabilities as they are being discovered instead of just only just like one day before the release, so that we save lots of rework because of that. The script to build and scan Docker images daily was written in Python. You may ask, why Python? It was really simple because this script was embedded as part of the CI pipeline that we run, and all the other steps in the CI pipeline was written in Python. But if you dig a little bit deeper into the data, Python is actually widely used for infra code at Facebook. According to a report from May 2016, Python is the second most popular language used for infra code at Facebook, just behind C++. And if you ask me, I will pick Python over C++ at any time, any day. And another additional reason for picking Python in this case, which is more particular to our use case, is that Python has a very mature SDK for Docker. So I use this feature of Python to build and scan the Docker images relatively easily. So here I have just shared one example about how Python has been used to automate the process so that you can get your product better for scale. And now we will move on to the second practice to prepare your product for scale, which is building self-serve tools. Let's rewind the clock back to the day when you had the big launch and users are flooding in to sign up for your product and your team are giving each other virtual pat on the back. And I want to break another news to you, and that is now you need to support it. As another quote goes, the quality of product support is critical to the success of a product. And now this quote is from no other than the presenter myself. Although I am not as famous as Jess Humble, not even nearly so, but I have feel I have a true feeling about this statement, and I have seen it play out many times in real life. Happy customers tend to bring in more customers, although word of mouth may not be the most viral or efficient marketing method in this time and era. I would still argue that it is the most satisfying way to bring in more quality users. On the other hand, if your customers are unhappy about how your product is supported, they tend to churn really fast. And that could mean a waste of both your marketing efforts and dollars. Even worse, the users may lose trust in the product or even in the company, which is a really bad thing of itself. You don't want to work so hard in building an awesome product, but only to tank it with poor product support. And I want to go a little bit diversion from software engineering, but I think this example should be relatable to some people on this call. Several months ago, I have decided to back up a mechanical keyboard campaign on Kickstarter because, of course, I want another mechanical keyboard on top of my 7 mechanical keyboards that I already own. But I was a little bit to the game. So when I backed the campaign, there were already mountains of people who have been waiting for the keyboard for months, if not years. Just 1 month before the actual release dates of the keyboards, some backers have found out that the keyboard has been on sale on an e-commerce website. What this means is that some common Joes can get hands onto this keyboard much earlier than these hardcore backers who have been waiting for it for months or years. This is definitely not good, but the backers are still rational, so they reach out to the creators and asking what is happening. But the creators handled the situation so badly that it resulted in a huge exodus of their hardcore backers. People are quitting the campaign and requesting for refunds. Generally, people are really upset about the company. For the people who didn't quit the campaign and eventually get the keyboard, they were pretty satisfied with the keyboard, like me. But for the damage that has been caused to the company from their most loyal backers, that trust, you can never get it back. So let's head back into more practical implications of how quality of product support is crucial to a product. If you are building an enterprise software, you normally will provide a service level agreement, what we normally call SLAs, to specify what type of support is to be expected from your product. And you may offer different levels of support based on the importance of the user. And breaking these SLAs will even have legal implications. One type of product support that is most familiar with software engineers is troubleshooting. Whenever we receive user reports about something not working in production, we do the following things. Firstly, we will check the dashboards to see if there's anything weird going on with our system. We will try to reproduce the error to see whether it is a widely applicable error or it is just some edge case that like very few users have run into. If none of these point to any particular cause in the system, it's likely that we will need to refer to the logs to understand what was happening before and after a certain issue so that we can have a mental map of the trace of events happening around the issue. Referring back to the challenges of managing packaged software, one of it is having little control over the environment. And we feel this firsthand when we are trying to support the WhatsApp Business API. Because the businesses need to install the Docker containers in their own environments that we have no visibility into, it can be really tricky to support it when they report some issues to us. To add on top of that, the lack of visibility not only comes from environment, it also comes from how the user configures the application, even what version of the application the user is running with, and what the user is doing when they discover the issue. One additional challenge about a product that we are preparing for scale is just the sheer amount of support requests that are coming in. And you can never scale up your team as fast as your customer scales up, the number of your customers scales up. So before you can answer the question of how I can scale my products, you need to answer this question first. How do I scale my product support? Looking across the industry, I have identified two ways to scale product support. The first one is the enterprise software support model, where you will put in dedicated support resources as your product grows. The other type of scaling product support is by building self-serve tools. And that is what I'm going to focus on for the later part of my talk. Building self-serve tools means that you empower the users to be able to check for common issues on themselves so that they can solve these common issues as much as possible on their own without needing to open a support ticket or asking for any help from your company. These self-serve tools should be built with the ease of use in mind, because we want to reduce the friction to adopt these tools as much as possible. Do we have any examples about building self-serve tools? And actually, in package software comes in many shapes and forms. So here I will just give two examples of developer products. The first one is Homebrew. This should be familiar to developers, especially using macOS. It is the package manager for macOS and for Linux as well. The other product that I want to mention as an example is Flutter. It is an UI toolkit for people to build cross-platform applications. What do Homebrew and Flutter have in common? I would want more interaction, but it is not possible in this call, so I will just show you the answer. They both have a doctor. What I mean by that is that both Homebrew and Flutter, they have a self-serve troubleshooting tool. For Homebrew, it's called Brew Doctor, and for Flutter, it's called Flutter Doctor. And these two self-serve troubleshooting tools are very easy to use because they are pre-installed with the main applications itself, and running them is just one command away. Both of them will check for common issues and suggest possible mitigation methods for you to solve the issues by yourself. Inspired by these two products, the team built a self-serve troubleshooting tool for the WhatsApp Business API client as well. It's what we call WhatsApp Debug. When the business installs this tool and run it in their own data center, what it does that it also checks for the common issues that normally comes with the installation and configuration of the WhatsApp Business API client. And it will offer suggestions if it detects a certain issue. This way, we are providing tools for the businesses to solve the most common issues on their own. But of course, not all the issues that the businesses run into will be the common issues that they can just be captured and solved by this list of common issues. So they still have the option to open support ticket to us if they encounter more complicated issues. In this scenario, what normally happens on our side is that when we check the dashboard, it normally doesn't show anything because the issue is normally particular to a particular business, not the entire service. And when we try to reproduce the error because we don't have access to the environment where the issue actually happened, so it's very rare when we can reproduce the error. So we have to resort to the last method to troubleshoot a certain issue, which is to get the logs. Of course, we have logs on the WhatsApp server side, but it helps little because again, normally these issues are very particular for a business. So we have to ask the businesses to provide the logs from their WhatsApp business API client so that we can decode the logs to see what we can find from there. And asking information from user is tricky to say the least, because we normally what user will provide are information that are incomplete or inaccurate or irrelevant because they don't know what you are looking for, and they normally don't have the right means to collect all of this information that you need. And because of the communication model between us and the businesses where support channel are asynchronous, so there is also this long feedback cycle. Whenever we want to ask some additional information from these businesses, we have to wait another day or two because of time zones and because the users may be busy with other things in their company. All of these contribute to a very delayed troubleshooting process. To solve this, we also built this additional option into the CLI tool called that I introduced previously called WhatsApp debug. We have this command that the business can run, and it will just automatically captures all the logs necessary for troubleshooting. And the businesses can just get these logs and append them to the support ticket. And the support team can just get these correct logs and relevant logs and continue to troubleshoot from that. The impact of the CRI tool, both with the common issue checks and with the logging function, is that it significantly reduced the support volume for common issues because the businesses can identify these most simple common issues themselves and solve it based on the suggestions provided from the tool. Secondly, whenever there are more complicated issues, the tool can help them to capture the relevant logs, and they can just grab that log and attach it to the support ticket without any much hassle from on the business side. All of these have led to the impact that support efficiency has significantly improved, which means that you will be better prepared to scale your product further. This CRI tool is built using Python. And why Python in this case? Besides the two reasons that we mentioned in the first section of this talk, that Python is widely used at Facebook and Python being having very mature SDK for Docker, in this case, Python also provides good tooling to build CRI applications. It also provides good library support for functionalities like networks and data utilities that we use to check for the common issues. Last but not least, my team also has fairly good Python knowledge, and this should always be one of the factors that you should consider when you want to decide which programming language that you want to build with. Now let's move on to the third and last practice that I found useful to prepare your product for scale, and that is about establishing a community. Building a community for a product means that you open up this communication channel between your company and your customers. It means to build a platform for collaboration, and the most loyal customers of your product should feel a sense of belonging to a larger group, and they should even consider using the product part of their identity. After all, this is how Apple built up their brand. Building a community for open communication means that you are building trust with your customers and you are able to collect feedback from your customers in very early product design stage. Building a platform for collaboration means that people can help each other out by answering each other's questions and even come up with new product ideas by discussions. And the users who have a strong sense of belonging to the product will become natural advocates of the product and bring in more customers just like them. Developers are not unfamiliar with the different ways of building communities around a product. And the most common way is using open source. Open source is transparent by default because every line of the code change can be contributed back to a certain commit. The users on the open source repo can collaborate each other by answering each other's issue questions and working on a fix or a feature together. All of this fosters the sense of belonging to contributing to the growth of this product. You don't have to open source your entire product because that is your core competency, but I still recommend you to think of ways to open source things that you think will be valuable, such as tools or even just documentations. Python has a very strong open source tradition. Actually, when I look into the data, Python is actually the second most popular language on GitHub in all the different attributes. To contribute to this Python tradition, we have also open sourced the WhatsApp debug CLI application from the start. As you may have noticed, it is not the most popular open source project on Earth, but it really doesn't matter because it sets up a platform for people to come together and have a discussion. And I would say that is important of itself. Another way to engage with your product community is by open communication with high quality content, such as newsletters and blog posts. So early this year, the WhatsApp Business API team has also decided to start sending email newsletters to the businesses who are using the API whenever there's a new release or there are some other major product changes. This idea sounds great, but how do we know if the businesses are actually finding these newsletters useful? Of course, one way is just directly asking them by interviewing some of the businesses or by surveys. But the anecdotes collected from this channel tend to be skewed towards the larger businesses who we have direct contact with, and collecting these anecdotes may be quite time consuming. Another more scalable way to understand how to improve the communication quality is via data. In this case, it can be just as simple as measuring the opt-in rates for the newsletters. Before you can do any data analysis, of course, you need to prepare the data by aggregating data from different data sources. And this is not simple, but at WhatsApp, we are blessed with a tool that makes this simpler by allowing us to build data pipelines. What it does is that you can specify data pipelines in terms of DAX, and you specify the task you want to run, for example, where you want to get the data from, how you want to transform it. And then you specify how often you want to run this task. And lastly, what this task depends on. To illustrate this idea in a very simplified version of how we measure the opt-in rates of the newsletter, I will show this example here. So in this job or in this pipeline, there are two tasks. And in the first task, we will get all the businesses that currently have access to the WhatsApp Business API because it's still in closed beta. And we will get the opt-in preferences of these businesses. The second task, which depends on the first task, will then upload this data created in the first step to our data warehouse, which we called Hive. I scheduled this data pipeline to run daily so that we can get this data on a daily basis, and we can build a dashboard on top of it to see a running view of the opt-in rates over time. All the Dataswarm data pipelines are written in Python. And why Python in this case? Firstly, it's because the program has fairly good modularities so that you can build really granular small tasks and then later compose them into larger pipelines or jobs. But arguably more importantly, being a tool that is mostly used by data scientists for them to prepare their data for their later data analysis, Python is a language that they are already familiar with, so they can just get started with a tool without a very steep learning curve and without additional intricacies. So now I have introduced and shared all the 3 practices that I found super useful in helping getting our product ready for scale. They are the automation of processes, building self-serve tools, and establishing a community around your product. For all the 3 sample Python examples that I gave during this talk, for all the 3 of them, when I get started, I never had Python in my mind when I get started. But because of the large variety of problems that Python is good at solving, I ended up solving 3 really different problems all with Python. And to me, that is the power of Python. That is the end of my talk. I hope you enjoyed it, and I hope it inspired you to continue to solve real-life problems with Python. And feel free to ask any questions now. Thank you.
Thank you so much. It was awesome talk, really, really insightful, really nice. I have a few questions coming in already, and I would start off with asking those. So first of all, what tool was used to scan Docker containers for vulnerabilities?
Yes, that is a very good question. We are using a third-party tool, but I'm not so sure if I can share the name of the tool just because of my company policy. But yeah, there are lots of these container vulnerability scanning tool in the market, and this particular tool, I use it because it is used for all the Facebook Docker security teams. As some of you may know, in Facebook, we don't use Docker containers for our other production systems. We use our own system of virtualization and scalability. But there are some products that we use that we build on top of Docker containers, such as WhatsApp Business API. So in this case, we have a central tool, but it's a third-party tool.
Mm-hmm. Also, has WhatsApp used React Native?
Yes, we do. Yeah, but although it is not related to WhatsApp, yeah, we do use React Native because React Native, like the entire React stack, is pretty widely used in Facebook.
Mm-hmm. Also, Facebook built hack for PHP. Have you or Facebook done something like this for Python?
That is a good question. I am not sure, but we use our own Python build tool called Buck. I think it's a little bit different from the common Python build tools that are used elsewhere, but Buck is also an open source Python build tool, and we use that. I don't think we built like a fresh new Python variety like what we do with PHP. Yeah, but we do have our custom toolings around that.
Also, is it hard to find good Python developers, for example, compared to Java developers?
Huh. I may not be the best person to answer about this because I am merely an engineer on a team. At Facebook, we normally believe in people who can, like, language can be learned, and it is just a skill that you can pick up when you are doing your job. So we don't really concentrate that much on like which language that you are most proficient with, because all the software engineering knowledge is pretty much shared within each other. So yeah, I although I may not know that answer, hopefully I gave some useful information with that answer.
That's great. That's all the questions that I have. I have gotten some amazing feedback from everyone who's been listening, that it was an awesome talk, very insightful, and everyone's very happy with all the information that you've actually shared. And you're also on Twitter, so I would just say to everyone that if they have any follow-up questions, they can probably just tweet to you and you can reply to them with whatever you are able to answer. But thank you so much. Thank you for your time. Thank you for joining us at PyCon Estonia and sharing all this information with us. It was very, very helpful.
Yeah, thank you so much, and thank you everyone for listening in and spending this time with me.
Thanks
a lot.
So for everyone, it's 3:50 p.m. over here, and we have our next talk at 4:20. So we have around a 30-minute break, and then we would see you in the next session. Ciao.